Hey, good morning everyone. Today I am going to discuss about locomotives and rolling stock. I am Dr. Vijaya Gowri, working as Associate Professor in the Department of Civil Engineering, VVRIT, Narsapur. Overview of today's presentation is classification of locomotives, steam locomotive, diesel locomotive, electric locomotives. This will cover under the classification of locomotives. Second one is rolling stock. In this we cover coaching stock, goods wagons. Classification of locomotives. The first locomotives which hauled the first train in India in 1853 from Bombay to Thane was imported from England and it was named as Falkland locomotive. These locomotives are used to take the train forward and these are nothing but the engines. This type of locomotive was the 240 type, which resembles the wheel pattern of the locomotive. Since more than 5,000 types of steam locomotives have been imported and manufactured for different gauges. Classification of locomotives. This classification of this table resembles the name of the locomotive. In that first digit resembles the gauges, which gauge is resembles. So, X or W digit resembles broad gauge, Y is for meter gauge and Z is for narrow gauge. The second digit in that particular name of the locomotive is A or L. It resembles light passengers, B or P standard passengers, C is heavy passengers, D or G standard goods and E is heavy goods, M is mixed goods and passengers, U, N, T, W is shuttle or shunting. So for example, if you see Y and P indicates Y is for meter gauge and P is for passenger train. And diesel or electric locomotives, one additional alphabet is also added in between the broad gauge and the first one, last one, that is D for diesel, A for AC electrical, AC electric, AC and C for DC. WAG indicates broad gauge AC electric locomotives, which is used to haul a goods train. W is for broad gauge and A is for AC, G resembles goods train. So this table resembles the axle load of the different types of locomotives and which can carry by the locomotive, overall length, IPH, maximum speed of the locomotive. So light passengers XA is taken this type of 75 km per hour and standard goods is 75 and heavy passengers we can see the speed of the train is 95 km per hour and heavy passengers for meter gauge maximum is 75, minimum is 55 and standard passenger for goods trains, it is 50 and standard passengers for narrow gauge, Z resembles the narrow gauge and so here 40 is the maximum speed. So here you can see the steam locomotive. In this is the schematic picture and here you can see the piston rod and which will be connected to the crank pin here and driving couple. These are the driving couple wheels and bogie carrier ideal wheels and here this you can see the firebox. Here we can see this one type of cylinder will be there and this is boiler consisting of firebox and tender is the some bogie which is attached to some part of the this steam locomotive. It's consisting of tender wheel and here this tender carries generally coal. So this is the real picture of the steam locomotive. Here we are going to see different parts of the steam locomotive. The first one is the boiler. So here the boiler is consisting of firebox, barrel and smoke box. So coal is fired in firebox and where the water is converted into the steam. The The smoke and gases from the firebox pass through the smoke pipe and finally get discharged through the this chimney. The chemical energy of the fuel thus converted into the heat energy of the steam. Here in the boiler, the chemical energy is nothing but the coal. Coal is burnt and then from that heat energy of steam is going to be happen. Steam engine. Second part of the steam engine is main part steam engine. The steam engine consisting of cylinder, piston and other moving parts. Just we discussed. It converts the heat energy of the steam into the rotary energy in the following manner. The first one, the steam from the boiler is first admitted into the cylinder fitted with the valve. This valve can be operated manually. The steam enters into the cylinder one side from the behind a steam tight piston that is fitted inside the cylinder. The piston can move forward and backward. Here the piston can move forward and backward. That will cause the movement of the crank pin and this particular coupling rod. This will cause the movement of the train, and here the linear motion of the piston is converted into the rotary motion and wheel parts are going to be rotating. The next part is wheel and frame. Wheel and frame is here. We can see this part, this particular part. The locomotive has an ideal as well as loaded wheels. The frame is supported on the wheels. It is carries the boiler and also holds the steam engine and the other parts of the locomotive. Tender. Tender here you can see the tender is provided behind the locomotive to store fuel. The tender is a type of mini wagon that is supported on the wheels and is coupled with the main locomotive. In Indian Railways, this is the old version of steam locomotives. Presently, it is not manufactured in the railways, not giving much importance. So, next one is the second one is the diesel locomotives. This is the schematic diagram of diesel locomotives. Here you can see the main parts are this is the battery. Battery you can see where here you can store the electricity, and then here starting fuse and battery, nice switch, and cooling system. Here you can see the cooling system, and here radiator and fan axis, and these are the wheels you can see, and this is the motor. Main part is motor, and engine part, this is engine part, this is the transmission part, and this is the front or mechanical part. This is the real picture of the diesel engine. It uses the diesel oil as fuel. Here, there we can see in steam engine, coal is the fuel. Here in the diesel engine, diesel oil is the fuel, and combustion takes place inside of the cylinder. The air inside of the cylinder is compressed and raising the temperature of the air. The fuel is injected inside the cylinder and causing the spontaneous combustion. The diesel engine mostly comprises of 4-stroke cycle consisting of suction, compression, ignition and exhaust. The energy thus generated is utilized for the driving of locomotive. The horsepower generated in diesel locomotive is transmitted into its wheels in the following manner. So there are the different types of locomotives, different methods of movement of diesel engine. The first one is the mechanical transmission in the case of conventional diesel locomotives. The hydraulic transmission in case of the diesel hydraulic locomotives. Electric transmission in case of the diesel electric locomotives. There are the 3 ways we can use to do the movement of the locomotives. Diesel electric locomotives have become quite popular because of its economy in operation, high tractive effort even at low speeds. All the standard mainline BG and MG locomotives in Indian Railways function via electric transmission. The different types of diesel locomotives in use on Indian Railways as follows. Broad gauge WBM1, WBM2, WBM3. This is the broad gauge diesel engine. Here you can see this is the meter gauge locomotives, that is YDM1, YDM2, YDM3. This 1, 2, 3 resembles the different versions. So Indian Railways has, however, recently standardized WBM2 diesel locomotives for broad gauge, the YDM4 diesel locomotives for the meter gauge lines. So both these locomotives are of the ALCO, Indian Locomotive Design, and currently being manufactured in DLW Diesel Locomotive Works in Varanasi. So WDM2 locomotives have the horsepower of 2600 and are capable of hauling weight is 3600 tons train load at a speed of 72 meters per hour on the level track. The maximum speed of these type of locomotives are 120 km per hour. The latest series of locomotives are also given here. WG2 locomotives for the goods traffic, DP1, DP2 locomotives for passenger traffic. These two are WDP1, WDP2 is for passenger traffic, and here you can see the WDG2 is for the goods trains. These locomotives have greater horsepower and superior performance capabilities. The third locomotive is electric locomotive. Here you can see the picture 11. This is the plan of the top view of that particular locomotive, electric locomotive. This is the side elevation of the locomotive. This is the front elevation. The width of the front width of the locomotive is 3 meters, almost 3 meters, and length of the locomotive is 17 meters. And here you can also see the different parts. Okay, the main parts are the 11 here the silicon rectifier block, where the electricity is taken from the main lines to this electric locomotive through this silicon rectifier block. So here you can see this battery, 7 is the exhauster, and 6 is the pneumatic braking system. Here you can see 5 is the air compressor. You can see here this one. These are the main equipment of this locomotive. This is the main original picture of electric locomotive. So these motors are drawn power from the overhead distribution system through the pantographs. These pantographs are joined frameworks conveying current to an electric train from the overhead vines, which are mounted on the locomotives. So there are the different systems of feeding power to these locomotives. Particularly, those are 1500 volt DC and 750 volt DC and 25 kilowatts of AC single phase and AC 3 phase. The most economical way of transmitting and distributing the power is to directly transmit the power at industrial frequency, whereas the motors are most suited the electric traction of DC series motor. So we are recommending in Indian Railways DC series of motors with AC power at 25 kilowatts single phase, which is having the industrial frequency of 50 cycles. The voltage is stepped down to the lower voltage by means of the transformer which is present in the locomotive, which is converted 1500 volts and 750 volts AC to DC by means of silicon rectifiers. And this power and then fed to the DC series motors inside the electric locomotives. This system has been adopted in India in 1957 and is based on the system adopted by the French National Railways. Earlier, Indian Railways had electric traction system that worked using 1500 volts DC and 3000 volts AC. The electrification of locomotive in India was first undertaken between 1925 to 1932 at 1500 volts DC. Consisting of, there are the different routes they have electrified. Those routes are Central Railways from Bombay VT to Igatpur and Pune, and 62 kilometers of road railway electrification has been done. Western Railways between Churchgate and Vihar, and 32 kilometers between the Madras Beach and Tambaram. These sections still use 1500 volts DC system to power their locomotives. In addition, 142 route kilometers around Calcutta were electrified using 300 volts DC system in 1954 to 58, which was subsequently been converted into 25 kilowatts AC system. So this table gives details of electric engines in Indian railway system. So this gauge is given, and AC or DC trains and type of electric locomotives. The first one resembles the name. These are the names of the different types of locomotives. So here you can see the first letter is related to broad gauge, and A is the AC, M is the mixed traffic, and this is the model number. This is the, here you can see this is for meter gauge. Y resembles meter gauge. So WAM1, WAG1, WAG3, AG4 are the locomotive based on the European design. Whereas WAM4, WAP1, WAM1, WAG5 locomotives are designed as per the Indian design with 6-wheel arrangement for bogies, which is similar to the diesel WM locomotives. Some of these locomotives are capable of hauling the latest type of box and wagons with the air brake arrangement. It may be mentioned here that the WAP1 is a passenger locomotive, has a vacuum as well as an air brake system, and is designed run at a speed of 130 km per hour. Rajdhani Express has this type of locomotives attached to take the train. This table resembles horsepower, weight, service speed, various locomotives. Here they have given this is the type of locomotives and their horsepower required to movement of the vehicle, and this is the weight of the vehicle, and this is the maximum speed. So VAP1 is giving the maximum speed of 130 km per hour. Passenger. P1 means this is a particularly passenger train. Next we see the rolling stock. What is rolling stock? Rolling stock includes locomotives, passenger coaches, goods wagons, and all other type of coaches, wagons such as electric multiple units, EMUs, diesel rail cars, and special wagons such as box wagons. Coaching stock. These coaching stock are the bogies, which are also called as bogies, which will carry the passengers from one place to the other places. And there are the different types of the passenger coaches, include the electric multiple units that are the part of suburban trains and conventional coaches such as second class, first class, second class sleepers, and AC 3-tier, AC 2 tiers, and AC first class coaches. In 1994-95, Indian Railways had a stock of 3,600 EMU coaches and 30,000 conventional coaches capable of carrying total of about 3.7 million passengers. These coaches have three basic structural designs. Those first one is designed by the IRC, which will be made with the wooden body. This is the Indian, and integral coaches built by Integral Coach Factory, Perambur, Chennai. Integral coach built by the Bharat Earth Mover Limited, Bangalore. This is Indian Railway design, and these bogies are ICF, and this is for BEML design. So this table resembles salient features of IRS, ICF and BEML coaches. They have given description over here. There are the different types, and they have been compared between the IRS design and ICF design and BEML design. So here the type of the body in IRS, wooden body, and here in this case light metal, ICF, and similarly for BEML also this is lightweight. So type of structure, it is a wooden body in IRS. For IRS, wooden body resting on rigid steel underframe. For ICF, all metal are welded integral coach of tubular construction. For BEML, this is similar to ICF coach, except that here load is taken by the floor. Coach dimensions are almost all similar to all the three designs, and damage during the collision and derailment is extensive for the IRS damage and less damage for ICF and the BEML because of the presence of an anti-telescopic structure in the end walls to absorb shocks. Goods wagons. Goods wagons are primarily meant for the carriage of goods traffic. Indian Railway presently is the stock of almost 0.29 million goods wagons with a haulage capacity of 10 million tons. These good wagons are mostly consisting of covered or open wagons, and as well as special wagons such as box wagons for carrying the coal or other bulk traffic. Until the middle of last century, particularly the goods traffic was transported in general purpose of wagons or in covered open high-sided and open low-sided wagons. The standard wagons on broad gauge was four-wheelers with a haulage capacity of 22.19 tons, whereas for meter gauge wagons, and it is carrying hauling capacity is 18.69 tons of goods. Recently, a number of new bogie wagons have been designed and put into services which lay emphasis on the higher payload and on the provision of facilities for the loading and unloading special type of traffic. These include BOX, BCX and BOBX, box and CRT wagons, etc. It has been decided that only bogie wagons will be put into service on railways, as the four-wheeler wagon is a non-viable unit in the present context of the bulk movement of commodities. The above mentioned classification of wagons, B stands for bogie wagon, C stands for centered discharge, and O stands for open wagon, X stands for high-sided, and Y stands for low-sided. N is used for air-baked and C is used for covered wagon, R is rail carrying wagon, T is the transition coupler. B indication is sometimes omitted as all new wagons or bogie stock. These are the different pictures of wagons: box wagon, BCN wagons, box wagon. This is the bog wagon. The people can sit inside, and this is the generally box wagons or open wagons are having they can also carry the coal, such type of things. BCN wagons or also carry some goods which should be covered. Boy wagons and CRT wagons. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.